Okay, here's question 2. Now, there's 2 ways we could do this question. We could say, okay, it's a quotient rule, and it's a weird quotient rule because the top isn't really a function of x, but we could say it is a function of x. The derivative of this is 0. Or we could be a little bit smart and say, okay, let's just bring this up to the top and then use this chain rule because we like using the chain rule. The chain rule seems, for students, its chain rule seems to be the one that creates the least issues. So let's see how we do that. Now, have I differentiated by moving this up? It's a positive power on the bottom, so when I take it to the top, it changes sign, that power. So it becomes 3x minus 5 to the minus 4. Now, I have not differentiated. I've just changed it, so it's in this form. Now, what are we going to do? Now we're going to differentiate. So we bring this power down. We're going to bring the minus 4 down, decrease this by 1. Bit tricky. You decrease minus 4 by 1 and you get minus 5. And then we've got to times it by what's inside the brackets, or the derivative of what's inside the brackets. So that's 3. So times 3. So what have we got? We've got minus 12, 3x minus 5 to the power of minus 5. Again, this is a correct answer. It is the derivative. It would be nice to write it in a different form, but this is a correct answer. How did I write this in a different form? And did I make a mistake? When this is to the power of minus 5, so when I take it to the denominator, I have to change this minus 5 to a plus 5. So I did get that wrong, but because I'm going through it, I can see that I've got that wrong. This is to the plus 5. When we take it up, it becomes minus 5. So just be aware of that. We can all make mistakes. That's why we show work in. Hopefully, the big trick here is to make this into a chain rule, and they will always try to get you to do that one extra step. Okay, thanks.